Hello, welcome to my channel. Let's continue with the tutorial on integration. But here we are taking the integration of a reducible fraction. A fraction that can be reduced. It is a fraction that has only one term in the denominator, one monomial. It is different from the one that has two terms in the denominator. So you can see this is a typical example. So first thing we do is that we are going to divide each of the term in the numerator by that denominator in order to get a polynomial term to integrate. Now before we can do that, we can see the top is also a product. X plus 3 times x plus 3. We have to first expand that. So that becomes integral of, if we are doing the, we square the first term, that will be x squared plus twice the product, meaning the product of the two will be 3x times 2 will give us 6x. Then you square the last number, which will be plus 9, all over our 2x to the power 4 dx. But we can also remember that if you have integral of k, a function of the x, where k is a constant or a coefficient, in the integration we push the k out before we integrate the function. So if I have a constant as a coefficient, I shift the coefficient out of the integral sign, then I integrate, then multiply by the coefficient. Alright. It is not like a constant term alone, it's a coefficient. So in this case, I'm seeing that I can write this fraction as 1 over 2 before the whole of this. So 1 over 2 become the coefficient. So now I'll have 1 over 2 integral of x squared 6x 9x to the power 4 dx. So now we can now do the reducible fraction, meaning dividing each of the term. So 1 out of 2 integral of x squared divided by 4 exponent 4, x exponent 4 plus 6x, x exponent 4 plus 9x exponent 4, then we have our dx. Don't forget, here we are also going to employ the principles of indices. Dividing numbers on the same base, you subtract the exponent, meaning x minus x squared minus 4 right here will have given us what? X to the power minus 2. Then here, since the 6 is already on top, we are going to have 6x, then power of 1 minus power of 4, this 4. That will give us 6x to the power what? Minus 3. I believe we do the same here. So the 9 will be up, but there is 1 here. So it's going to be 1 over x to the power 4 times what? 9. This 9. 9 times 1 give you 9. Then your divisions will come. But this is going to be a law of indices where we have reciprocal. So this becomes 9x exponent what? Minus 4. So now we are going to replace each of these fractions with their polynomial with a negative exponent. So this becomes integral of what? X minus 2 plus this, which is 6 minus 3, then plus 9x to the power what? Minus 4. So now each of the fractions is now reduced to a polynomial with exponent of negative. So now we can now do our integration regardless of the constant outside. So we know if you are going to do integration, let's say we have our 2 still out there, x to the power minus 2 plus 1, we increase the power plus 1, divide by the result, then plus 6 x to the power minus 3 plus 1 all over minus 3 plus 1. 9x to the power minus 4 plus 1 minus 4 plus 1 plus what? The arbitrary what? Constant. All this is multiplied by what? Our half. So now we can see that this arithmetic can be performed. So we have 1 out of 2 multiplying x to the power 1 negative. So negative 1 from there, negative 1 from here, plus 6. This become x to the power negative 2 over negative 2. This become 9x to the power negative 3 over negative 3 plus what? C. This is not part of the, this half is multiplying this before we add our constant to it. So now, what do? We are now going to simplify further. This, if this were to be 1, we will have maintained x to the power negative 1. But since it's negative, it's only going to affect the value here, making this become negative x to the power negative 1. Here, have a common factor with 6. So we can cancel that to get a negative 3 there. This can also have a factor with 9. So negative 3. So maintaining our half, this right here is going to be negative x to the power negative 1. Then this become negative 3 x to the power negative 2, negative 3 x to the power negative 3 plus c multiply. So now what do? We can see this as a negative exponent. Could also mean that I can have a fraction with the power of this being positive. I can have a fraction with the power being positive. The same here. But before I open the bracket, this is going to multiply. So this 2 is going to multiply the denominator of this fraction, which is the x. This 2 will also multiply the denominator of this, which is x to the power 2. Similarly, x to the power 3. So this is going to be minus 1 over 2x minus 3 over 2 as in this fraction. Then this is also coming down. So it's going to be x what? Squared as a positive. Then minus 3 divided by what? 2. But this is also 1 over x exponent 3. So I'll have x exponent 3. Then now plus what? C. So in all, evaluating this will give us minus 1 over 2x minus 3. We can rewrite this. So that the 3 sits on top. Like this. So this is the evaluation of this integral. So under reducible fractions, we can also perform integration by reducing the fraction to a linear term, or simply put, a polynomial with a negative exponent. Okay, so I think this concept is clear. If you grab the concept, let's evaluate the integral of 1 plus x to the power to the root of x dx. Evaluate if the concept of reducible fraction is clear to you. Try this and share your answer in the comment section. If you are new to this channel, please subscribe, like, share, and comment. And God will bless you. Bye-bye.